Imagine it's 2:43 a.m. You step outside, looking up to see the familiar night sky. But tonight, astronomers around the world notice something terrifying. That massive, colorful band of the Milky Way fades completely into darkness, obscuring millions of stars from view. Within days, the stellar landmarks we've relied on for millennia vanish from the night sky. The Big Dipper is gone. The belt of Orion wiped entirely clean from view. And when space agencies run diagnostics on their ground-based observatories, they find zero hardware glitches. The telescopes are working perfectly. The universe is still out there. We simply cannot see it anymore. Our entire solar system has been swept up by a colossal wave of dense cosmic dust and gas. For centuries, humanity has admired nebulae from millions of light years away, studying them as beautiful, glowing paintings suspended in space. Now, that same beauty has trapped Earth inside a pitch-black cosmic fog. This environment consists of a complex, churning mix of gas pockets, microscopic grains of dust, highly charged particles, and sprawling magnetic fields. The scale is almost incomprehensible. These magnetic field lines stretch across thousands, sometimes millions of light years, entirely dwarfing our entire neighborhood. We are no longer observing the distant mechanics of the universe through a lens. Earth is now a captive passenger inside one of the largest physical structures in existence. Down on the surface, the environment begins to mutate. As incoming sunlight tries to push through this dense cosmic dust, the light waves scatter. Midday sunlight softens, evening sunsets warp into deep reds, heavy purples, and bright emerald greens. That scattered, softened light triggers an immediate energy crisis. Without direct, unobstructed solar radiation, solar panels across the globe register a massive drop in efficiency, struggling to produce usable power. The highly charged particles floating in the cloud are doing the same thing to our communication grids. Radio waves struggle to punch through the interference. Global GPS networks begin to drift, and orbital satellites relay corrupted data back to the surface. Further out into space, the situation is terminal. The faint telemetry pinging back from our deep space probes hits the dense wall of the nebula and fades out entirely. With our local satellites failing and our deep space eyes blinded, humanity faces total digital and scientific isolation from the rest of the cosmos. Faced with the prospect of permanent isolation, the world's space agencies combine their resources. They design a heavy-lift expedition spacecraft, engineered to climb straight up and breach the upper edge of the nebula. After months of blind, grueling transit through the dust, the atmosphere outside the ship finally begins to thin. The expedition bursts through the upper boundary of the cloud, and for the first time in years, a sea of brilliant stars floods the sky. But when the crew points their instruments back down into the dense fog, they detect a massive thermal signature. Deep inside the cloud, gravity is pulling gas and dust together, actively igniting a brilliant newborn star. Caught in the massive swirl around that young star, heavy clumps of material are colliding and fusing. New planets are taking shape right beneath us. We have a front row seat to an active cosmic nursery. This is the exact environment responsible for the birth of new solar systems. Over immense timescales, as our solar system orbits the galactic center, it naturally drifts through regions of interstellar gas and dust. But there is a massive catch regarding density. This diagram compares the density of a typical nebula on the left with Earth's atmosphere on the right. No nebulae are incredibly diffuse. Their vacuum is emptier than any we can artificially create on Earth. The dramatic blackout you just pictured is a cinematic acceleration. If we entered a cosmic cloud today, the changes to our night sky and solar radiation would be subtle, playing out slowly over millions of years. While a sudden blinding fog is a science fiction extreme, our physical interaction with the surrounding galaxy is a real, ongoing scientific process. The exact atoms inside your body right now were originally forged in the crushing heat of ancient stars. When those stars died, the iron pumping through your blood and the calcium building your bones were scattered across the universe by nebulae exactly like the one we just imagined. Humanity is a biological extension of this cosmic cloud. Every atom in our bodies began its journey here, making this encounter a physical reminder of our direct connection to the stars. So, if Earth spent 100 years inside the birthplace of stars, would you want humanity to stay and watch, or build a mission to escape? Let me know stay or escape in the comments below. And don't forget to subscribe to Future Decoded, because sometimes the most beautiful places in the universe are also the most mysterious.